Alright, so today we are going to be looking at lesson 9.1, dealing with transformations. This is a new activity. Activity 9 deals with translations, reflections, rotations, but today we're just going to start with some transformations. So some of this may be concepts that you've heard in previous math courses. Some of them may be terms that you know. You may know a little bit about this, and some of you may know nothing about it. So this is our first lesson. We're going to work on this again over the next few days. But starting off, we are looking at a marching band at a high school. Mr. Scott is the director of the band, and he is using this coordinate plane to represent the football field. For the band's first show, they are being arranged in a rectangle. There are 6 marchers wide and 9 marchers deep. So you can see in the middle of the figure, there are 6 by 9. That's what each of those black dots represent. Then the band begins by marching down in that transformation is shown down here. So they start in this figure A, and then they go to figure B. That's transformation 1. Then the marchers move apart from each other vertically, but they stay in the same row, the same distance apart. So that goes to figure C. So those are transformations. So as you see in your book, a transformation is a change in the position, size, or shape of a figure. So that's what we are looking at, changing the position, the size, or the shape. So your book shows you pre-image and image. Pre-image is the original figure. That's what you start with. Think about the word pre-image. It has a prefix, pre, P-R-E. That prefix means before. So this is the image before we do our transformation. Our original image is the pre-image. Then, after you do your transformation, you have the image. So that's the resulting figure that you end up with at the end. So those are some of our new terms. I do want to point out the word transformation has the word transform as part of the word. That's a synonym for change. So when we are making a transformation, we are transforming our figure. We are changing it in some way. Now, some of you may know translations or a slide, reflection, where you flip it, rotation, where you turn it. Those are all things that we'll be looking at. Some of you may have heard of a dilation. We will look at those not in Activity 9, but those are some terms that you may have heard of in relation to a transformation in previous years. So the first thing that they ask for, in your own words, describe transformation 1. What happened from figure A to figure B? Our figure slid down. Rectangle A to rectangle B, we are moving it down. All of the marchers are moving down. You may be more specific. You may say they slid down by 6. They started here, and now they ended here. So they moved down by 6. They slid down. So looking at the next page, number 2 asks you to compare transformation 1 and transformation 2. Transformation 1 preserves the size and shape of the rectangle. Only the position is different. Transformation 2 expands or stretches the rectangle vertically. You may think that it's in the same position. That would be fine. The middle of it stays in the same spot. the size of it is not the same. If you look back, this figure is bigger than figure B. It is still a rectangle, so some of you may say the shape is still the same, and that's fine, but it's not the exact same size and shape as figure B. So some of you may have trouble. Look at the dimensions of the length and the width. On figure A, this one is 5, 1, 2, 3, 4, 5, by 8. 1, 2, 3, 4, 5, 6, 7, 8. This figure B is still 5 by 8. This figure C is 5 by 16. So you can see that they're not the exact same size. Flipping back to this page, number 3. Transformation 1 is an example of a rigid motion. So that's a new term. Rigid motion is a transformation that preserves the size and the shape. So a rigid motion is going to keep the same distance between points that are being moved, that are being transformed. So in this particular figure, that's the marchers of your band. The shape and the size of your pre-image and image are the same. They are the exact same shape and size. That's only for a rigid motion. If your shape or size change, then it's no longer a rigid motion. So how does transformation 1 affect the distance between any two marchers in the band? Well, let's go back to the figure. They represented the marchers with little dots. So there are marchers all along here. At every point is a marcher. The whole rectangle has lots of green little dots to represent people. In figure B, again, we have all of these little marchers, and you could continue going. For transformation 1, the marchers are still the same distance away from each other. The distance between any two marchers stayed the exact same. If you look now, part B asks, how does transformation 2 affect the distance between the marchers? How does transformation 2 affect the distance between the marchers? Is it a rigid motion? So if you look at the figure, we know that left to right is the same as left to right here. So left to right, the distances are the same. So in each row, the distances are the same. However, up and down, vertically, this distance is not the same as this distance for the figure C. So some people may think, okay, they added more marchers. There are more people in the band in the last figure. That's not what happened. It's still the same number of people in the band. What happened is that these rows spread out. Instead of having the rows super close together, now they're a little bit more spaced. So we still have the same people, just vertically they're spread out more. So now let's look at number 4. We are going to look specifically at transformation 1. Each point in the pre-image, that's figure A. That's what we're starting with before we do the transformation. They are mapped to our image, which is figure B. And we're going to look at how each individual point gets moved. So they have given you in this table, figure A, the pre-image. Those are the four corners, the vertices of our rectangle. And we are trying to figure out how they are changed when we look at figure B. So we're going to go and look at our rectangle. So the first corner that they gave you was the top left corner. They said that was 110. And then when we look at the top left corner of our rectangle on the new figure, that figure is mapped to 1, 4, which is what they put in your very first row of your table. Then the next point they gave you is 1, 2, which is the bottom left corner of your rectangle. The bottom left corner of your rectangle is 1, -4. So that's what should go in your next box on your chart. Then they give you 6, 10. That is the top right corner. And the top right corner on figure B, your image, is 6, 4. Then the last corner is 6, 2. The bottom right corner is 6, 2 on the pre-image. On the image, the bottom right corner is 6, -4. So I'm going to fill in those on the chart. So that's what we just did with our graph. Just plotted each individual vertex. So they want you to notice a pattern. So if you haven't seen the pattern, take a second, pause the video, look and see if you can find the pattern. So, how does the transformation change your x coordinates? Your x coordinates are what comes first. So your x values are 1 and 6. On the image, there again, 1 and 6. So, the x coordinate, there was no change. They stayed the same. For the y coordinate, this one may have been more difficult to see for some of you. The y coordinate was 10, 2, 10, 2. On the image, 4, -4, 4, -4. So, how did it go from 10 to 4? Again, we have another 10 to 4. And then these are 10 to -4, 2 to -4, and 2 to -4. It went down by 6. You could also word that as subtracting 6. It decreased by 6. It went down by 6. So, now what we're going to look at is something called a mapping notation. So they write an example of it here. The book that I have used for the last 8 years calls it a mapping notation. You may call it that. This particular book calls it a transformation, one as a function. So you write it as a function. You're not going to have f of x, for those of you that are familiar with functions, but the way that you write it looks similar to this notation. Over here on the left, you can see the arrow in the notation means goes to. So when you go to write this, we're going to begin with a general point xy. It goes to And we're trying to write, for any point on this figure, how could we rewrite it? What happens to it? Well, we just said the transformation does not change the x-coordinate. So the x is going to stay, if we start as x, it's going to stay as x. The y does change. We just said it went down by 6. We subtract 6. So whatever our y starts as, when it gets transformed, it's going to decrease by 6. So that's how you would write that notation for that mapping function. So now let's go to the next page. On this page, we're using figure B as our pre-image, and then figure C as our image. So this first column should actually be the same as what we had on the previous page. So we have 1, 4, 1, negative 4, 6, 4, and 6, negative 4. And then I'm going to go back so that I can look at the graph to get the other column. So we are going to be looking at figure C. The top left vertex of our rectangle is graphed as 1, 8, which they gave you in your chart. The bottom left corner is at 1, negative 8. The top right corner is at 6, 8. And the bottom right corner is at 6, negative 8. So we can go and fill those in on our chart. So then, it asks, how does the transformation, so this is transformation 2, how does it change the x and the y coordinates? So the x again are at the beginning. We have 1, 1, 6, 6. On the image, we have 1, 1, 6, 6. Again, there is no change, stays the same for the x coordinate. The y coordinate. This one may be more difficult for you to recognize. Pause the video for a second. Think about it before we move on. Some of you may feel like the y coordinate, it goes up by 4 or down by 4. And that's true. But when we're looking at transformations and how they affect the x and y coordinates, we are trying to make it so that it's the same thing for every point. So not every point goes up by 4. Some of them go up by 4, some of them go down by 4. So can you think of a different way that changes every single coordinate? And if not, that's okay. But the way that it changes, it multiplies by 2. If you start with this y value, multiply by 2 to get that y value. If you start with this y value and you multiply by 2, you get that y value of negative 8. So if you multiply each y value by 2, you will get the image y value. So that would be the y coordinate change. So part C asks, can transformation 2 be expressed as a function? It can. How do I know that it can? Every point, every marcher does the exact same idea. They do the same thing. Every single point on that figure has the same transformation occur. So, what happens if we start with our point x, y. Well, we said our x doesn't change, so we keep it as x. Then our y, we said multiplies by 2. So we can change that to 2y. So that would be how we could write that transformation as a function. So now we're going to look at number 6. They give us the function, and then we are supposed to graph the image. They gave us the pre-image function. So this mapping says that we're going to take the point x, y, and it's going to get mapped to the point x plus 3, comma, y. So this x plus 3 means that our x values are going to increase by 3. X is your left to right, or your horizontal movement. So all of our horizontal points are going to move to the right by 3. So some of you, when you look at this, you may understand exactly how to graph it, and you may be able to do it and move on. Some of you are going to have a little more trouble, and you need to look at it point by point. And that just depends on how your brain thinks. Doesn't mean you're smarter than one person, or you're not as smart as another person. It's just how does your brain comprehend what you are seeing on the page. So if you've got how it works, then you may not need to listen through this entire video to understand how each of these work. I'm going to go point by point for those of you that need that instruction. So I'm going to start with the top left corner of our square. That point is 2, 5. Remember, your x value is left to right, and then you go up 5. My transformation takes my x's and adds 3. So this 2 is going to have 3 added to it, so that it's going to become the point 5, 5. And the y isn't changed. So now my top left corner is at 5, 5. Then my bottom left corner that's at 2, 2, I'm again going to add 3 to my x value to make it 5, and my y value stays as 2. So that's where the bottom left corner would get mapped to. Using the same idea, our top right corner is currently at 5, 5. My x value gets 3 added to it, so it's going to become the point 8, 5. And then my bottom right corner is currently at 5, 2. And when we add 3 to our x value, 5 plus 3 becomes 8, and our y value stays as 2. And so it'll be placed right there. And so our figure is there. And as you can see, looking at side by side, it's the same basic shape. It's just shifted over by 3. So it asks, classify the transformation as rigid or non-rigid. The position was changed. However, the size and the shape are identical. We didn't change the dimensions. So it is a rigid transformation. It did not change size or shape. It's still a 3 by 3 square. So that's why it's a rigid transformation. So now we're going to look at part B. If you feel like you can do this, go for it. And then you can pause the video and practice it, and then unpause it and fast forward if you think you've got it. But I'm going to go over it step by step for those of you that need that additional practice. So on this one, we're taking the point x, y, and we are multiplying the x by 2, and we're multiplying the y by 2. So, our top left corner of our rectangle is currently at 1, 5. So if we multiply both of those values by 2, we are going to end up with 2, 10. So this is where my top left corner should go. Then my bottom left corner is currently located at 1, 2. When it gets mapped using this transformation, and I multiply the x and the y by 2, I'm going to get 2, 4, which goes there. Then I'm going to do the same process with the top right corner. So it is currently at 3, 5. So when I take that and multiply them by 2, I'm going to have 6, 10. So that is where my top right corner of my rectangle will go. And then the last corner that I have is the bottom right vertex. It is currently located at 3, 2. So when I multiply both of those by 2, I get 6, 4, which is going to be right here. And so this is my new figure. That is my image that I just traced. So, is this a rigid transformation? Is it the exact same shape and size? No. So it is non-rigid. So now number 7 asks you, write the numeral 4 in the middle of each pre-image that we just drew. So they want us to put the number 4 in each of our pre-images. Then it asks, how should it appear in each image? So think about a picture. If on part A we had a 4 in our square, on the image it should still be the exact same shape and size because nothing changed about the size of that figure. It just got pushed over. It's like you took it from your desk and put it on your neighbor's desk. For part B, it should be the same shape. It should still be 4. It didn't get changed to an 8, but it got bigger. Both left to right and up and down. Horizontally and vertically, our X and our Y both increased by 2. So it should be twice as big left to right and up and down. So that'd be like if you took a piece of paper to a copier and you enlarged it. It's not going to change a 4 to an 8 on your print. It's just going to make them bigger. So now we're going to look at number 8. So flip it over to the next page. These are ones, it says check your understanding. So you want to try these and then unpause the video and I'm going to go over them. So looking at number 8, they tell us that this rectangle undergoes the transformation described by the function x, y goes to x minus 2, y plus 1. So I'm going to do this point by point for those of you that are having trouble with this. So it gives us a box, and it says the first coordinate is 1, 3. So that's our bottom left corner of a rectangle. When you apply the transformation that they gave you, our x value starts as 1, 3, and then our y value is 3. And we are applying 1 minus 2 and 3 plus 1. So if you simplify that, you get negative 1, 4. So the pre-image point of 1, 3 on our image should be graphed to negative 1, 4. And so we can go ahead and graph that. We're going to go left 1 because it's negative, and then up 4. I'm going to use green for 1, 7, which is our top left corner of our rectangle. So again, we're going to plug 1, 7 into our mapping function. So our x value is 1, and our y value is 7. And if you simplify that, you get negative 1, 8. So on our image, this top left corner should be negative 1, 8. And so if you graph that, you should end up at negative 1, 8. I'm going to use red for the next one. I'm going to do the bottom right corner. So that currently, for our pre-image, is at 10, 3. If we do the same idea, plug it into your transformation function. Your x value is 10, and your y value is 3. That gives the point 8, 4. So on our image, we're going to end up at 8, 4 for our bottom right corner. And then the last one, our top right corner, is currently located for our pre-image at 10, 7. And so if you apply the same formula, 10 is our x, and our y is 7, we are going to end up with 8, 8 for our image coordinate. And so if you connect your dots, you end up with that rectangle. So hopefully you understand how that works. So now let's look at number 9. It says graph it, which we just did. Is the transformation a rigid motion or non-rigid motion? And explain how you know. Is it the exact same shape and size? Yes. So that means it is a rigid motion. So over here in your book, a rigid motion can be modeled by sliding, rotating, or flipping a figure. A non-rigid motion involves stretching or compressing it, typically. So that's kind of how you might know if it's rigid or non-rigid. Another way you may be able to tell, if you cut out one and you put it on top of the other one, they should overlap exactly. So now let's look at number 10. A rectangle is transformed as shown. So we start with this figure and as our pre-image, and then our image is this figure on the right. So what happened? Your rectangle moved down. So if you look on the next page, they say, for part A, which function describes the transformation? So I am going to look at this at one point to another point. This point on the pre-image, how does it map to that point on the image? So you may just want to take it and put it over here and then literally count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It went down 12. So that'd be one way. Another way to look at it is this is point 1, 10, and then it ends at 1, negative 2. And so you can see the x value stayed as 1, 1. The y value went from 10 to negative 2. And so that mapping notation, xy, goes to x, y minus 12. So that'd be the function that describes that notation, that transformation. Then part B asks you to classify it. Is it rigid or non-rigid? And explain why you classify it that way. This would be a rigid transformation because the figure remained the exact same shape and size. Okay? So now we're going to look at 11, 12, and 13, which were for homework. So let's look at 11. It asks us to graph the transformation and then ask if it's rigid or non-rigid. So here is the mapping function. Looking at that, it says xy goes to x and then y over 2. So that means our x's are going to remain the same. Our y's are going to get divided by 2. So I'm going to start off by looking at the bottom left corner. That point is 3, 2. If I apply the mapping transformation, 3, 2 is going to go to 3 and 2 divided by 2, which is 3, 1. If I look at the top left corner, that is the point 3, 8. So if I apply the function to 3, 8, that's going to go to x value still is 3, 8 divided by 2, which is going to be 3, 4. So if I graph that, I will have 3, 4 for my top left corner. If I look now at my bottom right corner, I have the point 9, 2. So if I apply my transformation function to the point 9, 2, that's going to go to 9 and then 2 over 2, which is 9, 1. Then my last corner that I have is my top right corner. That vertex is at 9, 8. And so using my transformation function, that's going to go to 9 and 8 over 2, which is 9, 4, which maps to right there. And so this would be the graph of the image of the figure. So is that a rigid transformation? No. The figure changed size, it changed shape. It's not the exact same anymore. It was a square, now it's a rectangle. So that is not a rigid motion. It says for number 12, draw a plus sign in the middle of the image. So I'm going to do that in blue. That would be exactly halfway, left and right and up and down. In the image, the plus sign would now be more like that. And so as you can see, left to right, it's the same. The width is the same. The height is going to be half as much as it was. The y value got cut in half. So the height should be about half. So now let's look at number 13. Use the graph of the rectangle to help you classify each of the transformations. We have the transformation described by the function x, y goes to x over 2, y. And it asks us to classify this as rigid or non-rigid. So, if you took our rectangle that they give you, this point here that is at 1, 3 is going to go to 1/2, comma 3, which is about right there. This point here that's at 1, -3 is going to go to 1/2, comma -3. This point that is at 4, 3 is going to go to 2, 3. And then this point that is at 4, -3 is going to go to 2, -3. So if you were to write those in your function, you would have 1/2, 3, 1/2, -3, 2, 3, and 2, -3. Which, if you graph just the new points, it'll look something like that. So, clearly, those are not the exact same shape and size. So that would be a non-rigid transformation. Now, part B wants us to classify this new one as rigid or non-rigid. So it takes our x's and stays as x, and our y goes to y plus 2. So our points 1, 3, 1, -3, 4, 3, and 4, -3 are going to have a different transformation this time. The x value stays as 1 and 4. Then the y value adds 2. So 3 plus 2 becomes 5. -3 plus 2 becomes -1. And then again 5 and -1. So if we graph this, we end up with this rectangle, which is the exact same shape and size. So this is a rigid transformation. So hopefully that helps you with lesson 9.1, dealing with transformations.